look at business use cases. So the first use case is fraud detection. Okay, so here a fraud is actual true condition or positive condition, and a non-fraud is actual negative or a actual false condition. Okay, so in this case, the recall metric becomes very important when compared to precision. That is because you shouldn't miss out on a true positive, right? So all the recalls should be identified by the algorithm. So fraud should not be missed over here. It is okay to classify non-fraud as fraud and then analyze further. So the F1 score is also useful over here because it will be a imbalanced data set. If you take the number of frauds when compared to the overall number of transactions, it will be an imbalanced data set. Okay. Now let us look at the spam detection case. So here a positive class is nothing but a mail which is classified as spam, and a negative class is a non-spam document. Okay, or a non-spam mail. Now here what happens is that here precision is very important. Okay, so we cannot have a lot of important documents getting classified as spam or getting predicted as spam. Okay, it is okay for us over here to miss spam once a while, right? So precision becomes more important than recall in this particular case, as the cost involved with the important document getting classified as spam is more than the correct detection of spam. Okay. From our confusion matrix, we can also compute a lot of other metrics. So we already know recall. Recall is also known as true positive rate or sensitivity. It is nothing but the sum of true positives divided by sum of condition positive, which is nothing but the sum of true positives plus sum of false negatives. Okay. Similarly, you have precision, which is also known as positive predictive value, which is nothing but the sum of true positive divided by sum of predicted condition positive, which is nothing but the sum of true positive plus sum of false positive. Okay. Now this is with respect to the positive class. Now with respect to the negative class, what kind of measures do we have? So we have specificity, which is nothing but this, or the true negative rate, which is nothing but the sum of true negative divided by the sum of condition negative. So sum of condition negative is nothing but sum of false positive plus sum of true negative. Okay, so this is like the recall for the negative class. Similarly, for the negative class, you also have something like precision, which is negative predictive value, which is nothing but sum of true negatives divided by sum of predicted condition negative. So the sum of predicted condition negative is nothing but again the sum of true negatives plus false negatives. Okay, then we have F1 score, which is 2 into precision into recall divided by precision plus recall. Then you also have accuracy, which is true positive plus true negative divided by total population. Okay, now let us look at some more business use cases. So for a medical test, we would want both sensitivity and specificity to be high, right? Both are important. So recall is also important and true negative rate is also important. Okay. Now this would turn imply that you also need less false positives, right? Because for specificity to be high, the true negative rate to be high, we need to have less false positives. And for recall to be high, we need less false negatives. Okay. So with respect to rare disease data, it will be an imbalanced data set, right? Because the prevalence of the disease is very rare, right? So here recall becomes more important because we don't want to miss on, a person with a rare disease. Okay, it is more important than precision. But if you take the case of an airport security where you have some kind of a machine learning algorithm, implemented in some kind of device to detect explosives or some kind of unsafe bags, recall becomes more important than precision because every unsafe bag needs to be detected. Certain safe bags can be marked as unsafe and then you can manually look at it, but every unsafe bag needs to be detected and it cannot escape the security check.